All right, so now we're going to talk about different shapes, trapezoid to be exact, of how to find area under a curve. So trapezoids have these tilty tops, right? And an area of a trapezoid, just so you know, is 1/2 the base times height 1 plus height 2. Height 1 times height 2. So for this one trapezoid, I have this height and this height. So there's two heights, 1/2 the base times height 1 times height 2. Okay, so just to give a little bit of an idea where this formula comes from, let's just say I'm finding the area of this trapezoid. So this would be the height 1, this would be the height 2, the base, I'll call that width there will be delta x, right? So the area of that trapezoid will be 1/2 delta x h1 plus h2. All right, so let's move on to the next trapezoid. So the area of, and I'll call this height h3. So the area of this trapezoid will be 1/2 delta x, because again, the width of each of my trapezoids will be delta x. Then I'll have h2 plus h3 plus. Then if I move on to my next trapezoid, there would be a height 4. So then I would have 1/2 delta x, and then I would have h3 plus h4. Okay, so just even looking here to see what I've got, I can see that I could pull out the 1/2 delta x out of every single one of them, right? I'd have one of these h1s, and then look at this, I would have two h2s, and then I would have two h3s. And that would go on until I ended, and I can see here I have one h4. So that's what this pattern is saying. So delta x over 2, part of the area of the trapezoid formula, a coefficient of 1 here in front of the first edge point, the first height, coefficient of 1 here in front of the last edge point, and then coefficients of 2 on all the middle ones. All right, so again, we're using trapezoids to approximate the area under the curve, because the exact area under the curve is that long way that you're doing on your take-home quiz. So this is saying start at x equal 1, end at x equal 5. This is the function. We're making 4 trapezoids. So we need to start with our delta x. Our delta x is b minus a over n. B minus a over n, so that gives us 1. So we really just need the number line. So 1, 2, 3, 4, 5. Okay, so the trapezoid rule is delta x over 2, and I'm going to have a coefficient of 1 times my f of 1. I'm going to have a coefficient of 1 times my f of 5. So those are the two end points. And then I have a coefficient of 2 times each of the inner heights. Remember, I'm building these trapezoids, so each of the inner heights. So notice there are not 5 terms added, right? There are not. It's the trapezoid formula, so it's not going to be 1, 2, 3, 4. I'm sorry, not four terms added, like adding up the area of 4 trapezoids. There are 5 terms, and it's because of the formula of how to find the area of trapezoids. So then the last step would be to plug 1, 2, 3, and 4, and 5 into the function, and this would be a fine answer. All right, Simpson was actually a weaver, and he was contemplating what kinds of rectangles, so trapezoids gave a better approximation of area under the curve. He thought about having rectangles that have tops that are parts of parabolas. So that was even a better way to get the approximation of the area under the curve. So I'm not going to go into this explanation. In order to do Simpson's rule, you have to have an n that is even. The delta x over 3 is in front for Simpson's rule, whereas for trapezoid it was delta x over 2. Again, I have a coefficient of 1 in front of my first edge point and my last edge point. Now look at this very unique pattern. So it starts with a 4 and ends with a 4 before the edge points. And then what do I have going on in the middle? 4, 2, 4. So it alternates between 4 and 2, but it always will start and end with a 4 in the middle points. So looking here, area between 1 and 7 of this function with n equals 6. So you first find the delta x, made it 1. So make up the number line. I just wrote out the numbers that we're looking at. So I'm going to have this 1 times f of x 1, 1 times f of s 7. So those are the two endpoints. Okay, so then now I start the 4, 2, 4 pattern. So 4, 2, 4, 2, 4. Starts with 4, ends with 4 between the two edge points. And you're using these values that you found from the delta x. So I've used f of 2, f of 3, f of 4, f of 5, f of 6 for those middle values. Again, there are not 6 items in here, right? 1, 2, 3, 4, 5, 6, 7. There's 7. So there's not 6 items that we're adding. It's because of the formula. So I just finish off by plugging in 1 and 2 and these numbers into my function, right? And I get that from inside here. And that is Simpson's rule.